Okay, so we'll be going the end of the C1. Okay, we'll be going with the end one. So let's quickly write these things. The most three important one is this, right? Where is the Rohit? I usually see these 4 5 students coming up there. All right, it's no problem. So you have imported these things, right? And heat map, as we discussed yesterday, if we open yesterday's file a day ago, 50. If we discuss like what we had yesterday, open, yeah. So we went up through all these things, and where it is, where it is, where it is. In the last, we saw some graph, like not a graph, a plot, a matrix plot, basically, you can say. We got this, right? So, what our aim is to find this map, to explore this heat map, right? To know what exactly is heat map. Okay. Okay. It is very important because most of the time we use this heat map. Okay. So heat map has many parameters like for data, vmean, cmap, center, robust, a lot of things are there, right? Okay. So what this heat map does actually, just plot a rectangular data as a colored encoded matrix. Okay. So it has excess level functions and it draws a heat map. It draws a basically you can say rectangular data, right? You see a rectangular data you'll be getting on. Okay, so you get these things in a lot of contents and a lot of states, you can say, right? So we will be doing just a lot of things. Okay, so let's say uh, also import this library. Hmm. So let's say I'm taking np dot random dot c. Hmm. np dot random dot c and that of 0. Okay, and yesterday what we did, we are going to set. Okay, frame is unable to join. Rejoin once. So like let's take a uniform data. Okay, and let it be lp dot random dot random number from 10 to 12. Hmm. And let's give some access to it, and just quickly plot the heat map of this data. So we get some random numbers and some values over there, right, according to this data, right? And what are these things? How you get it actually, right? So we'll go to it. Okay, we'll go to. For now, let's understand that if you want to change the limits of a color map, right? If you want to change the limits, what you are getting, right? Like you can see, you are getting 0 0.2, 4, 6, and 8, but you want something different, right? You want to change the limit. What you can do is, you can in place of this plotting, one thing, single thing you can say, like you want the minimum to be the 0 and the max vertical value to be like 1. If you say it to be from 0 to 1, so it will be plotted from 0 to 1, and like what you write, it will be plotted as such. Okay, so that is fine. It is a thing of how heat map works. Okay, so now we will be going to discover the heat map in much detail. Okay, in much detail with that. Okay, so let's say we take up some of a content, like we know how to extract the data from there, right? Okay, so let's plot a data frame with like meaningful rows and columns with those things. Okay, so why this frame is okay? Frame is there, fine. So let's plot up with the data. So let's take flight data. So how can you take it? Load data set, and the data is flights. See up the head of this. So you'll see some years, some months, and the passengers. That means that in which year and on which month, how many passengers travel exactly. Okay, like that. Fine. Now, say that I'm saying this f is equals to f dot pivot of months, year, passengers. If you see your f, you will be having a data of the month, right? Then the year and the passengers. Understood? So this is how your f is now looking like. Okay, fine. You are having the years, right, and the passengers inside there, and then you are having the month over there, right? So that is pivot. Okay, fine. Now you want to plot a graph of this pivot, right? You say SNS dot heat map of this f. So you get a plotting like this, right? That is, if you see your limit. So again, if you want to set your limits, you can set the limits as we mean. Let's set it to be 100, and V max, let's say to be 1000. So this is your data, right? Okay. Now what this means actually? This means that the area which are black, totally black, the area which are totally black is having almost 100. Okay, as like the things goes lighter, so this is completely like in the red section, so we can say the red section is here. So here in 1960, in the month of July and August, we can see some 600 and above, might be in 550 to 660 range. So you can say this much travelers were there, this was passengers were there, right? So now let's say if you want to even find out like how many were there, right? So we'll be using a naught, right? So a naught is a boolean or like a value of you can say if true, if you give a naught equals to true, okay. So it will write the data of each cell. Okay, it will then write out the data of each of the cell if you write a naught of true. Okay, so we will be doing the same. Okay, we'll be doing the same, and there is one more parameter that is called as fmt. Okay, fmt is nothing but a string. Okay, and it's optional also. So string formatting code when use adding annotations, when you use annotate, you can write on fmt. Okay, so this is like how let's give an idea to you. So let's say I'm plotting this SNS of f with some v mean equals to 100, some max value equals to 1000, and as I say, I'll be using a naught, and if I say false, then it will be similarly like this. But if I say true, that's okay. And also fmt equals b. So first remove it, you will see the difference what it comes. So this is the data. Understood? Now if you write fmt, that will be a clear things, right? So this actually formats the thing. If you're having values over there, that actually formats the things. Okay. So you're getting a clear vision of the, you can say, like the travelers who travel, right? So we say like this was having 600, so it is correct, right? It is having some 600 range. But the max number of people, max number of passengers traveled in the year 1960, and also in the month of July and August. Okay. So see, now if in the heat map you want to give your if you want to give your mapping some line limits, if you want to give some limits to your line, let's remove this. It will look better. So if you want to give some line colors or limits to this, right? So what you can do in that case is like you say line width, or you can say it like that. So heat map L, and let's say line width to be 0.5. Okay, and let's make it something bigger. Big size is 10 cross 10, 8 cross 8. Fine. Okay, let's plot this. So you can see, like, right, that is the line width among all of these things, and like it's fine, right? 5 cross 5 is also fine. Okay, let's give it as, why is it always, okay, fine. So it is like this. Okay, you can give a larger value, that was okay. Okay, now let's say if you want to change the color of your mapping, if you don't want these colors what are coming instead of like that, so if you want some different colors, we again yesterday we saw how many colors we are having, how many mapping types we are having. So let's take anything from here, right? How many you are having? Around if you see these things, right? So how many are having? You have a lot of things, right? You can count on. Okay, so it take any one among this. Okay, so let's take anyone. Like we yesterday we took something as that was what really a new one. Yes, this is I'm using for the first time. This the spectral. Okay, that's color is nice. Okay. So what you do is just you can give okay, let's read. Let's say this f, and you want to give a C map of this, right? And let's take out the size again. Okay, so if you plot this, so you will see some different mapping colors, some different colors over there, right? Like this. So if you take on some different, like let's say if we take blues, yeah, so that will be like this. Any color, like this is nothing but the mapping. Like orange is my favorite one, so you can take it like this. Okay, fine. This is like how you can set on the things. Okay, now in a heat map, what more you can do is you can map the plotting on very specific types, like on the you can give some specific values in the center and like that. Okay, so let's say if we are plotting SNS dot a heat map, and we say that we want a data of f, right? And our centered elements, we are saying f dot locate, and now you know these things, right? So let's take it as January, January 1955. Okay, let's take 1955. So this I'm giving as my center value. Okay, and I'm taking it as oranges. Let's say for purples. So you get a data like this, right? Is there any good color on this? Hmm. Let's take this. These are the common ones. Let's take something different. Oh, cool. So blackish one there, right? That is not. You can go with rainbow. Nice. So what exactly are getting some? If you locate these things, right? So what you are doing, you are trying to locate the center as the January 1955. Okay. So that is in the center position. If you see, right, that is in the center position, and like if you again write it as n naught equals to true and fmt equals to d, so you'll get the data to there like this. Okay, you'll get, and you can even make it more bigger. Clear perception will come there. Okay, so that can be done, right? Okay, fine. So a lot of things you can do with the heat map. You can check for, like, we do these things for, like, in the cases of checking the nulls and all those things. Okay, so we can plot out the things with on the basis of the data, and like rest of the things are easy, right? Let's take any data. Let's load Titanic data and we'll show you up. So TITANIC and is null. Okay, first let's load the data. Okay, so this is T SNS load dataset, and Titanic we are loading on. Okay, so if I just give you an head of this data, so you'll come to see, like, you have survived, you have class of the people, you have their sex, their age, the siblings and the spouses, their parents and the children's, their fare, embarked, and all those. So we'll be training one model with this. Don't worry, we'll doing this today. Okay, we'll train a model with this one, and also we'll go with some different types. Okay. So this is like the fair embarkment class, and these are the reputations of this. Like the S stands for Southampton, C for Cherbourg, Q for Queenstown. So if we take a data of 10 1, so here you can see that there is one Q, yeah. So this Q stands for Queenstown, right? This S and C and all of that. Similarly, you can write some NAN and all those things here. Okay. Now let's take, you are saying this V is equals to T dot pivot. Only if you run this, so it is saying that no columns and nothing has been selected on, right? So if you say okay, so everything has to begin age. Still, let's do okay. Okay, fine. So let's just see how many null values are there. So like you can see like so many null values are in the deck side and in the age side, right? There are so many null values there. Hmm. Okay, so that can be seen easily from here. Having a lot of null values there. Okay, that is very dark to see. So yeah, this is nice. So deck is having a lot of null values. Similarly, the age is having a lot of null values, and you are getting every row number and like that, which is having some null values over there. The most which can be presented over here, it's being presented. Okay, and the ranges you are having from 0 to 1. Okay, so the darker color means that there is some null values. Okay, there is some null values. If it is not dark, then that is not a null value over there. Okay, that is how you get. So if you see not null, the graph will be simply different like this. So these blue are the spaces which are not null, and these white are the spaces which are null. Okay. So this orange will be the or brown will be the spaces like that. Okay, fine. So like this is how you get your and you can also set on the things right for the uh, let's say to be your limits. Okay, so heat map works is like this things. Okay, now we'll go to a bit concepts of machine learning and all those things. Okay, fine. So if we just say on for the machine learning, what is machine learning and how these things works, we like quick access, reasons. So there is one where it's machine learning. Okay, so we will quickly try to understand what is machine learning, how these things works. Okay, and then like I said, at the end of your session, like you have to make some models and then okay. So we will try. Okay. So machine learning is yeah. If you can see it from here. Okay. Right. So first we'll try to understand like what is the need of machine learning, why we use this machine learning, what is the importance of this. So like if you go with the introductory part, right? So machine learning is the most in demand technology in today's market if you see for that, right? Its application range from self-driving cars to predicting deadly diseases such as ALS and all those things, right? So the high demand for machine learning skill is motivation behind what I'll be dealing now. Okay, so we will be now we'll be studying on like how to implement machine learning, how to get the concepts of machine learning, and a practical implementation using some models over there, right? So, what was the need of machine learning, right? So, ever since the in the technical, like can say revolution, we have been generating you can say good amount of data, right? We are generating a good amount of data. So as per the research, like it was generated around 2.5 quinton of bytes of data every single day, right? And that is like estimated that by 2020, like 2020, 1.7 MB of data will be created every second for every person on the earth. Okay. And with the availability of so much data, it is finally possible to build predictive models that can study and analyze complex to find useful insights and you can say deliver more accurate results. Okay, so like there are top of the companies which are using these things, right? You can say for the Netflix, the Amazon, the Facebook, the Instagram, and a lot of this are there, right? So this company builds such machine learning models using tons of data in order to identify profitable opportunities and to avoid some unwanted risk. Okay, so they use these things for their own purpose, right? We'll be using for our concepts. Okay, so, like there are a lot of things which you can do with machine learning. You can increase the data generation. You can go with the improvement of decision making. You can go with solving complex problems. You can find some uncover patterns in your data. So that you can do, right? Okay, so machine learning is particularly like the first term. This machine learning, the first it was termed by Sir Arthur Samuel in 1959. Okay, and if you look back, probably some years back, it was the most significant terms in the technological advancements. Okay, so if you just go and browse through about what is machine learning, you will get at least 100 different definitions, so more than that also, right? So how very first normal definition was given by Tom M. Mitchell. Okay, so he said a computer program is said to learn from experience, that is E, with respect to some of the classes of some task T, and performance measure P is its performance at task in T as measured by P improves the experience E, right? So that might not be a good one to make you clear, right? That what happened here? Connection lost. Oh no, shit. My connections lost. Okay, my connection was lost. How many times ago? When I went through up there. What was the last thing you heard from me? Yes, yes, yes. Because I was going on. I was keeping the definitions to you, and I just saw up here and I saw there's no one. So the intro of ML machine learning introduction. Okay, yeah. So I was okay, fine. So where was the drive? Yeah. So machine learning, if we go on a basic thing, so machine learning is a set of rules. Okay, so not set of rules. You can say machine learning is a concept which allows the machines to learn from themselves, right? To learn from learn from themselves, but only if we give them some generic data and all. Okay, so it is a concept which allows the machine to learn from examples and the experience they have, right? And that too, we give some generic algorithms and all those things. Now what are these algorithms? So algorithms is a set of rules or statistical techniques used to learn patterns and data to draw significant information, or you can say it's the logic behind a machine learning model. Okay, so there are a lot of algorithms. We'll go one by one, we'll see. Okay, so, what is a model when we try to understand what is model? So, a model is the main component of machine learning. The model is trained using machine learning algorithm. All the algorithm maps are taking decisions. That model is supposed to be given some inputs or the correct like that. Okay, so your main goal is to make a model, right? So you have in machine learning, you have training data. a testing data, a predictor variable, a response variable, and all those things, right? So what is training data? So the machine learning model is built using a training data, right? The data which is used to train your model is called as training data, and then you take some part of it to test on, and that is called as your testing data, right? And the main motto is to make some models with that, right? Now, a machine learning process goes like first you go with the you define the objective of the problem statement, right? First go with the objective statement, then you go up for data gathering, then you prepare your data, then you explore your data, then you build a model, then you go for model evaluation, and then finally you go for the prediction. Understood? That are the things you go behind all of this, right? You go with these things, right? Now, see, so this is like use cases. Now ever you went to a shopping like online and you find things over there, right? Now you're here, yeah. So you find things over there. Similarly, you can go through the PPTs, right? We'll do the practicals because we'll have to end today. So how machine learning works? It's a kind, you can say, I have defined, right? You have a data training data set and testing data set, and then you work with that, right? So there are three kind of machine learning, you can say types basically. So supervised learning, unsupervised learning, and reinforcement learning, right? So if we define on the things, so supervised learning is okay. Let's go with this. Don't go with this one. So supervised learning is one where you have an input variables x and an output variables y. Okay, and then you create some mapping function to define the things from there. Right, you define the input to the output. Okay, so there you apply some mathematics basically. In all the algorithms, you will be applying some of the mathematics part. Okay, right. So supervised learning is something where you have one trainer. There is one trainer to actually define that this is wrong, this is correct, this is this is to take the input and this is not to take as an input. So there you have some trainer over there. So if we go with a practical example, so let's say these are the apples you're having. You give this you pass this to the supervisor, right, or the instructor or the trainer, you can say. So the trainer prepares a training data set on this basis of this, and also it gives the desired output of this training data set. So if these are the inputs, what should be the outcomes? So that is also being passed over there, right? And then an algorithm is built out. Okay. So this algorithm process this went to a process over there, and at the end in the process, you will get a model trained. Okay, you get a trained model out there. Okay, that is like nice. Okay, and that is the model which has been trained. Now you feed some like you can say unseen data, right? You feed some unseen data in the model, and you will predict whether the machine is predicting correctly or not. So see, it's an apple and it's predicting correct, right? So on the basis of some features and all those things, it has been predicted, right? So we'll move up, not with that. Okay. So you can see this supervised learning is used most of the cases in the Cortana, the weather applications, the biometric attendance, right? The next is the unsupervised learning. It is like the process where you have unlabeled data, right? In supervised, you have some labeled data, right? In this unsupervised, you have unlabeled data. Unlabeled data in the sense of like you can say that there is no trainer, no instructor, no one is there. You are left alone. The data is left alone to learn from itself. Okay, so how actually we human learn from the environment? How we learn? And let's say you are watching a cricket match, or let's say you are watching a football match, right? How will you learn from there? If you don't know anything about the football or cricket, how will you how will you get to understand what's going on, right? You will see like there is one batsman who is batting on, there is some one bowler, and there are some fielders in the ground. So you can, and on the basis of their jersey, you can differentiate that okay, these are the two opponent teams. Okay, one who is batting, and you can see the scoreboard, and then you can define that okay, the batsman is from this team and the bowler is from this team. And like if this is a game, if a ball goes on the boundary, then it's like 4 or 6, and then you can make some concepts of your own, right? You can make some perceptions of your own. So that is how you learn from the environment. Even if you don't know, you come up with some of the knowledge with that, right? So that is called as unsupervised learning. There is no one to make you learn. And in the reinforcement learning, what happens? So if we compare the supervised and unsupervised according to the data set, so there is some labeled data set in supervised. In unsupervised, you have unlabeled data set, right? The method of learning in supervised is a guided learning, right? As there is an instructor and it tell you there. So in unsupervised learning, you have to learn by yourself, right? The data has to learn by themselves. On the basis of complexity, supervised learning is very simpler as compared to unsupervised learning. It's computationally complex, but accuracy, the supervised are more accurate as compared to the unsupervised. So we prefer to go with the supervised learning always. Okay. And the classification versus clustering, you will see. Okay, this is a graph. This actually classification is something which classifies on the basis of their, you can say, the types. Okay, classify on the basis of the type. Like it will classify as, like you can see, there are hens, there are rabbits, there are birds, there are like animals. Okay, so classification, what classification will do, it will take all animals one side, it will take all birds one side. Okay, that is a classification, that is these are the animals and these are the birds, that's it. In clustering, what will happen, it will take exactly these animals, exactly these birds, exactly these rabbits and these hens. So clustering is making a group of similar types, and classification is differentiating these things. Okay, understood. So that is classification and clustering over there. Now we come to the reinforcement learning. So it is a learning that can be done as a hit and trial method, you can say, right? What we do in chemistry in class 11 and 12, right? A chemical reaction process and all those, right? So it is like similar to the hit and trial. If you are correct, the you can say the agent is given a reward. If it is not correct, then it has been giving a penalty over there. So it gets to understand like that. Okay. So let's quickly come up to these things practically. Okay. Let's go with some of the more definitions and all. So how many algorithms are there in the machine learning? Okay. So if you see the type of algorithms or the number of algorithms or how we can go with all those things. Okay. So the first comes as the classification algorithm. Okay. So classification is where the category is predicted using the data, right? And here you get the questions like, is this person is a male or female, or is the male is a spam or not a spam, right? So classification is a supervised learning approach in which the computer program learns from the input what you give to the machine, and then it uses its own learning to make the things to observe the things, to classify the observation what it has seen, right? So that is like in the classification algorithm we do. And the question and the examples, you can say it's like speech recognition, handwriting, biometric and documentation. Okay, so first you give the machine a data, you give feed a data and then let the machine to learn from itself, and then it comes with such an output. Okay, fine. Then we go to next. So it is used, that is anomaly detection algorithm. Okay. Now this is where you identify some unusual data points, right? Well, this is a technique that is used to define an identity unusual pattern that do not confirmed or expected behaviors as your, you can say your entities, right? So it has been many applications. It has many application in business, like for the intrusion detection, the identifying strange patterns in the network traffic that could like hack a signal, or the fraud detection. These can be used in anomaly detection systems. Okay. Next is the regression algorithm. So this is one of the most important thing. We'll be solving problems on the regression. We'll be making a regression model. Okay. So regression is where the data itself is being predicted. Okay. So it is one of the most important broadly used ML and statistic tool which allows to give you the prediction on the data, right? So basically what it does, it creates a relationship between an independent variable and a dependent variable. Okay, it creates a relationship between these two things, and you have some dependent and undependent variable, that is nothing but your features and your predictions, or you can say features and your outputs will go in that. Okay, so here you might have questions, you may have questions like what would be the market price of their house in some next years, is it going to rain tomorrow or not, like that. Okay, That could be a questions of regression type. Next, we come to see the clustering, and if you go for the clustering, so clustering is nothing but you create some similar groups over there, right? If we go with the clustering points, so you can say here we used to group the data based on some conditions, right? For example, you can say which type of users are going to buy this product, which type of user would like this songs, like this Spotify does. Okay, so this clustering is a task of dividing the population on data points into a number of groups. Okay, so that you can say the data points, and data points are just divided in the same groups. Okay, so the total aim is to separate groups and make them in a cluster. That's the main point of doing clustering. Okay, so you have different type of clustering: k-means clustering, hierarchical clustering, overlapping clustering, exclusive clustering. There are a lot of things. Okay, so like clustering algorithm done. Okay, now there is some feature selection process. Like feature selection process is like where you select your own features, where you select the features which are most important, and like on the basis of their importance you select some features over there, right? So what is exactly, how many kind of feature selection process are there? So there are three kinds. Okay, is this white? So first one is filter. Okay, there you have three different kinds: the information gain, size-square test, and the correlation coefficient. Okay, and the next one is for your wrapper. The next one is here as wrapper, and then here also you have like recursive features, elimination, generic algorithms, and like that. Okay, and the third is embedded. Okay, it's like it is embedded. Okay, and that is decision tree you're having over there. Okay, now let's quickly come up and see how these things works. Okay, see, now let's say this is your data, right? Let's say this is your data. What we do is, what is training and testing data set, guys? You have this data. Let's suppose you are creating some testing and training data set over this data, right? So what you will do, you will make some boxes over there. Like you will, let's say this is species is particularly our column of output, right? This is the output column, we can say, right? So we'll divide this data, right? We will give some divides to this data. Let's say this. Okay, now I'll say this part as x dash, this part as, okay, just take it as x, don't take it as x dash. So this is x and this is y. Now I say this as x dash and this as y dash. Okay, so if when we go to train a model, what we do exactly, we feed this x to the model. In the training process, we feed this x, whatever the data is here, and we feed also the output of this x to this, that is then x dash. So we feed both the x and the x dash, and we then come up with the training data set, and that comes with the model. Okay, that generates a model. Now to see the accuracy, to see how much the model is correct, how much the model is predicting nice, so there we give some data again to test on it. So we'll take a small part of this data set, its own data set, and then we'll pass to this model, the y, and on the basis of the y, it will be predicting the y dash. So we want to predict the y dash. This will be our outcome, or you can say the prediction, and we will see is it exactly predicting the same or not, right? So that is like you go with the types. Okay, fine. So okay, now let's just say if we define here. So what is your x? That is your training data. What is your x dash? X dash is your x test data. Okay, what is your y? Y dash is nothing but y testing data, and the y is the y training data. All right, so you have these things as well. And when you go with evaluating the model, then what is the thing you have to see is you have to see your y training data plus your the x testing data and the x training data. Okay, that is your model, actually what you get from the model. Okay, then let's say you want to evaluate your model, you want to see your model evaluations. So in that case you will be testing it with the y test data. Okay, that will work with the y test data. That is how it works. All right, cool. So now we'll go to like see the first, like our main goal is to complete the regression one today, right? So we'll be predicting models on regression types. Okay. So what is regression? If we go to understand the linear regression and all those things. So first we will have to try to understand that what is regression itself. Okay. So like if we define this regression, so it is one, like we have defined it, right? That is a form of predictive modeling technique which creates a relationship between an independent variable and a dependent variable. That's it. Like it's a clear vision of that. So you have some dependent variable and some independent variable, and then you create a relationship between them, right? So you have dependent is also called as your target variables, and the independent is called as your predictors. Okay. So dependent variables are the features. Sorry, dependent variables are the variable what you exactly want to predict. Okay. And independent are the factors or the features on the basis of which you are going to predict your data. Okay. So basically, if you want to create a relationship between a dependent and an independent variable, you need a term called as regression. Okay. So linear regression in some simple terms is a dependent variable which is continuous in nature. Okay. So that is a straight line you will be getting in your graph. Okay. Fine. So for a simple linear regression, okay, first we'll try to understand what are the use cases. So we know the use cases are like determining the strength of the predictors or for the forecasting things and like trend forecasting, all those. Okay. So for comparing this linear and logistic on the basis of the core concept, we'll see the data is modeled, the probability and all these things. See, in the linear regression, what happens? You get a graph where you have a straight line. In logistic regression, you get a graph which is a sigmoid graph, okay, like that. In used cases, if we go for the linear regression, it is like you can see a continuous one. It keeps on increasing and like that. Okay, it might be like this or it might be like this, right? In the logistic, you have only the 0 and the 1. You only have the variables in the 0 and the 1. That is categorical variable, and this is continuous variable. In the output or the prediction, these here the values are predicted. These values are predicted, and here what happens? Here the probability of an event is predicted. Like if it is something over there, like we give a threshold value here, some threshold here, and we get some if it is 0 or if it is 1, like that. Okay. So accuracy of godness of it, like you can say, like that is the process where we find the how much correct is the model. Okay. So here you have measured by loss, R squared, adjusted R, and all of these methods to find. In this logistic regression, you have accuracy, you have precision, you have F1 score, ROC, confusion matrix, and these things to be measured from here. Okay, cool. Fine. Now going ahead. Now selection criteria is a bit easy. Like use cases is also you have seen. Okay. Now before going to this, okay, let's go. So in linear regression, now what is linear regression? You have understood, right? So in linear regression, let's say this is your x and y, dependent and independent variable. You make a graph from here, and that is like a line which is called, this line itself is called as your regression line. This line is your regression line. Okay. So let's say I have y which is increasing, and let's say this is x which is increasing. Okay. Again I am increasing my y, and again I am increasing my x, right? So I'll get a graph from here which will be a positive graph, right? But now let's say that my y is increasing and my x is decreasing, right? Then in this case I'll get a negative graph out there. Okay, that will be a negative graph. So similarly, this line what we are getting as a positive or negative line is nothing but the regression line. Okay, that is a linear regression line. Okay, now let's say that this is an observation. Okay, and we took some more observation, like let's take one more observation. Similarly, we take a lot of observation and we'll try to plot this on the line. Okay, so like this is one observation, another, then next, and like this we take up some of the observations over there, right? And that is nothing but your regression line. Okay, that is your regression line, or you can say that is, we'll be finding these things on the basis of your least square method. So this is your regression line, you say. Okay, and you have plotted some data over there, right? You have some data points over there that might be x and y and some of this. Okay, so now, so let's say that one of the point is this. Okay, just take one of the point here. Okay, let's take it one, and what we'll try to do is we'll try to see the exact distance between this. Okay, we'll try to find the exact distance. This distance between the estimated value and the original value is called as your error. So our main focus, our main goal is to reduce reduce this error, like how much we can bring this point closer to this line, or how much we can bring this line closer to this point, so that we can get a best fit line for this, right? Best fit line which can hold all the possible values. Okay, fine. So we'll try to make all these lines very similar or very close to this particular line. Okay, so our main goal is to find this, right? So every point is to be close with this one. So, okay, we try to just make close all these things close there, right? So let's say this is a speed and the distance over there. Okay, and we are again taking a graph. So that will be a positive graph, right? Similarly, let's take y equals to mx plus c, because we know that straight line equation is y equals to mx plus c, right? This y is nothing but the thing you want to predict, that is your distance traveled. At the x here is the speed of the vehicle, and the you can say m, which is the positive slope of the line. Okay, so that is y equals mx plus c, and c is nothing but the y intercept of the line. That is we want to write. So we actually want to find the value of this m and the c, and on this basis we can make some linear models over there. Okay, so let's say this is time and speed, and this time we are getting a negative relationship of the graph, and that would be y equals to minus mx plus c. Okay, understood? So in independent and dependent variable, if we say on this basis, this is okay, this would be plus. So this will be plus. So y equals to plus mx plus c, and this is how a relationship occurs between a dependent and an independent variables. Okay, so dependent variable, this is independent variable, and now we'll try to understand this regression algorithm. Okay, so let's say you are having x as 1, 2, 3, 4, 5, and let's say you want to plot this on the x side. Okay, so this is 1, 2, 3, 4, 5, and 6. Okay, similarly, let's take y, which is 3, 2, 4, and something like that. Okay, so we'll plot quickly, we'll plot the y. So this is y. Okay, now we see that this is x1 and y, this is x1. For x equals to 1, y is equals to 3. So we'll plot this x equals to 1 and y equals to 3, and we get a point that x is equals to 1, y equals to 3. Similarly, we plot 2, 4, 3, 2, 4, 4, and 5, 5. Okay, and that is if we find the mean of this x-axis, so we find it to be 3. So we'll pass a 3, we'll pass a line from this 3, and similarly for this y, we found it to be 3.6. So we'll pass a mean of that, right? And on the intersection line, we'll in this point we'll make a they will make a circle over there, and we'll actually locate that point, that is 3 by 3.6. Okay, that is the line, and we'll pass out a line from there. That will be the best fit line from where most of the points will be much closer, and you can see like every points are closer to this, right? If you pass from line from here, in case of that, if you pass it from here, then like it's good. Okay, fine. So for finding in y equals to mx plus c, for finding the c, you have a formula of summation of y multiplied summation of x square minus summation of x, and then multiplied by summation of xy, divided by n, which is the number of rows you are having, multiplied by summation of x square minus summation of x whole square. So you find the summation of y, which add up, and you get to see y equals to 18. Similarly for the x, it's 15. And then you find summation of xy, which multiply x into y, and find that all the things, right? Similarly for the x square and that. Okay. So what would be the summation of x whole square? That is summation of x whole square, that is 15 whole square, and that would be 225. Okay. Now we'll plot all these things and we'll come to see the x c equals to 120 by 50, and that is 12 by 5, which is 2.4. Right. Now our main goal is to find the m. Right. So m formula is n multiplied by summation of xy by minus summation of x into summation of y by these all things. Okay. So similarly we write all these things and we find that m is equals to 0.28. Okay, that's nice. So we have y equals to 0.28x plus 2.4. Now we have m and we have c and we can write. So we can calculate now for the rest of the points. We can also calculate on the we have done with 1 to 5. Can we calculate now for the 6 to 10? We can calculate. Just we have to put the values over there, 6 and 7 and all those things. And that's an easy process now, right? So like for the 6 and 10, right? For the 6, the y is equals to 10. Like for the 7, it's 12, 8, 13.5, 9, 17 and 10, 20, right? And then we will get a quick graph of this, okay? So this actual versus the predictor graph you are having, okay? Like that we came to like end up with this small things, okay? Now let's go to our, okay, yeah. So let's go to our file today and we'll make some predictions and all those things, okay? So let's quickly start up these things. So time, okay, we have 1 hour. So let's load the data from here. There it is. Okay, this is, I don't need. Let's just make it LR. Okay, linear regression. That's nice. Okay. Now also one more thing. In a linear regression, you have two type of regression itself, right? You have simple linear regression, you have multiple linear regression. Okay. Now simple linear regression means that your data will be predicted using only one feature. Okay, only one feature. And in the multiple linear regression, you will be having multi features out there. Okay. So in simple linear regression, your you can say your equation comes as y, which is your predictor, is equals to alpha naught plus alpha 1 x1. X1 is the feature what you want to do. This is the regression coefficient and this is also regression coefficient, the intercept you are getting. Okay. And the multiple linear, it would be alpha naught plus alpha I xi plus alpha 2 x2 plus 3 x3 and so on till alpha n xn. Okay, like that again, right? So this is the multiple where you have multiple features out there, and here you have only one feature. So first we will try to make it with one feature. Okay, so with one feature, let's load with the data. Okay, so linear regression. Okay, fine. So first you will have to import all the important libraries that's required and all those things. So let's quickly write up one. Okay, I think we have imported everything in the first. Okay, still. Okay. So as I said, the first part is, what is the first part? To define an objective. What is your objective of making a model, right? So what is your objective? Here, what the data set I am using is charge versus battery time. So here we are going to find the time limit in hours or you can say we want to find the survival of a battery of a device on the basis of its charge time. That's it. Okay, so this is your objective. So let's read the data. Now since my data is in Excel format, I'll be using Excel, and that is lr.excelSX. That's cool. So if we just quickly print the data, so you'll see you're having charge time, and on this charge time your battery would be something like this. So how many data you're having exactly? So having some 1000 data. Fine, cool. So now you will prepare your data. So it's prepared. You don't when you're working in one single feature, you don't have to go with all of much of the things to work. Okay. That is a prepared data. Okay. Now let's say, okay, let's just say that with this data, whatever you have generated, okay, you are just going to predict some charge battery hours. Okay, or you are going to predict the battery hours with this, right? So let's quickly make these things in like list. Go with the training part quickly because yeah. So we'll see the columns. So these are the columns, and then we'll make the columns to list. So these are my columns. Okay. Now we'll begin our training phase. We'll begin the training data. Okay. So in training data, you have to define your x and y. So my x and y would be, so my first x would be the charge time, right? And what about y? So y would be the battery life, right? This would be x and this would be y. If I define my things, this would be the x and this would be the y. Okay, you take it as, also take it with the values. So this is your x and y. Okay. Now there is one, like I can say it's a formula or a method. So this line you have to write down, that from sklearn dot a linear model, you have to import linear regression. Okay, and then name the model as LR. Whatever you want, you can write. You can write your name even. Then pass this linear regression function to this. Okay, and then just fit on. So since we are doing with one variable, that's easy. So just fit it as x and y. So that's done, right? Now you can see your m. Remember the m we discussed just minutes ago. So this is your m, and you can write your c, which will be the coefficient. Sorry, intercept. If you see your M and C, you'll see this is your M and this is your C, right? The M and C. Now with this M and C, you can quickly find out any of the things. If you want to test your data, you can quickly find any of the things. Let's say you want to predict. So you can, when predicting the data, you can go with the predict. Okay. So you want to predict, let's say, uh, is X you're having. Let's say you are charging for 23 hours. What should be the battery life? It should be 123 hours and something like this. Okay. This is on the basis of X you are predicting. Okay. And if you want to see a graph for that, whatever the model you have made, linear regression graph, the X and Y to be plotted out, and say color equals to green. Let's just plot it, and this is a graph you are getting. Understood? With some points over there. This is the point, and you can see if we just zoom on, we can find it. These are the points, and this is the things over there, right? That is a linear regression graph. Okay, this is like the one feature modeling, right? With one feature, you have modeled something, and like you have tested your data over there. Right? Fine. Now, let's say you are making something with more than one feature, like you are going with the two of the features, right? More than one feature. So for that, let's take out iris data, and let's just load this iris, and so this is like your data where you're having sepal length, sepal width, petal length, and all those things, right? So how many kind of category species you are having? That is, again I'm repeating this. So that is what is it there? Okay. So versicolor 50, Virginica 50, and Setosa 50. Okay. So quickly just plot the species. Let's let it be. Okay. So now we are trying to just find out on this iris dataset. We'll try to find out the features, right? We'll try to train this on the basis of iris dataset. Okay. That is again an easy process, but requires something. Okay. So let's start with that. So we have some 150 data over 5 of the columns, right? So if we just plot a LM plot to see the lines, if you say just to see the lines over there of the plottings, if you say that this SNS dot scatter plot, a scatter plot of sepal length versus this sepal width. We did it yesterday, right? With some huge semantic of species and the data to be iris, color to be red. So you will see this data over there, like a scatter plot of the data. That's nice, right? You can see a scatter plotting of this data. So similarly, let's say that if I want to plot if I'm plotting a LM plot, that as for machine learning, we use these things basically. Let's take it to be Y, petal length, sepal width, and let's give you semantic as the species and the data to be the iris, and let's plot this. So you will get like a data with some of the lines. These lines are nothing but the regression line. Okay, that is a regression line you are getting on there. The best fit line you can say. So this is not these are the basic ones again. A basic line you are getting over there and your data. Now you need to make it perfect, right? So what you'll do, you will see the iris columns and you will make it to list. So these are these things. Okay, fine. Now similarly, let's just take the x and y. Okay, let's just take out this x and y and we'll pass on these things. Okay, we will pass the things over there. Let's take this is iris. These are our features. For y, it would be only the species, right? So if you see your x, these are your x, okay? Or if you see not values, so these are your x, okay? And what are y? These are the y. It's clear, right? So these are the x and these are the y. Now you want to make it in some linear regressions. So from sklearn dot linear model, have to import linear regression. Okay, make the model name and pass this linear regression to that model and then fit the x and y there. Okay, you can even split out the data if you want to split up the things and you want to find those things on the basis of after splitting. If you want to check it, the things you can also go with that. Okay, okay, 1 second. Okay, so like could not convert this string into float. Oh shit. So it is not converting. Okay, all right, then if it is not taking so we'll pass on the logistic one. It will take with the logistic. So it is string. We have to convert this in some random numbers. So that will also take some 0 and 1, and that will be a exactly categorical values. So let's pass the logistic one and then fill this. Done. Okay. So logistic has been done. That is nice. You can see logistic has been given. So that can be done, and if it is done, then to let's take with the classification reports and all. So classification report will give you some uh, data, right? So let's say we are going to predict the data, and that is ir dot predict of x, right? That will be our predictions. So let's say, so if we see our predictions, these are Setosa and all these things, right? Okay, this will be our values, what we are going to actually predict the things. Now if we see a confusion matrix of this, so let's say the CM is equals to confusion matrix of this y and this predictions. Okay, so let's give figure axis for subplots, and let's say this fixed size to be 4 cross 4. Okay, and the image show of CM and the C map to be oranges. So let's write this as axis and set the ticks and all those things. The set ticks. Yesterday we did like the ticks, what are ticks and all. So let's set this as 0 and 1, and then we'll mention the tick labels. So let's it to be the predicted zeros, okay, and the predicted ones. So because your data, once you just convert this will be in predicted zeros and predicted ones, right? And let's just copy this, paste. So when it will print there, you will get to see what's happening. Alright, fine. So actual ones and predicted ones. Now, okay, answer. Fine. So now let's set the y limit. So I say it to be 0.5. Okay, so let's say for I in range, because we are going to make a box of that, so for I in range of 2 and for j in range of 2, so ax dot text j comma 1 cm of I and j, and give it as center black. take it to white. Any errors? Confusion matrix is not defined. Okay. Function object has no attribute of set. Then line number 5. Oh. So you see what is thing you are getting. That is the actual zeros predicted to be 50 and the actual ones predicted to be 47. Okay. So you get a confusion matrix of this, right? That is the actual zeros, and here you have the zero. Okay, let's change this uh, format because it's not visible. The white ones are not visible. So you can see zeros and ones over there. Okay, if you could see it there. Okay, let's take something different. Blues would work. No, that is not good. Oranges are better. So actual 50 values are there, right? Actual zeros are 50 and the actual ones are 0, right? And predicted zeros are 0 and the predicted ones are 47, right? Understood? So you might not get all these things, when it will come only when you practice other things. Okay, so when you find your intercept, this will be your intercepts, right? So on the basis of this you can then predict other things and then you can make it up. Okay, you can even predict the, so how you will predict, when you will see for the predictions. So the predictions, what I say it is IR dot predict of x. Remember, this is IR dot predictions of x, right? So if you make a confusion matrix and if you don't plot it actually, so just make a confusion matrix, so you'll get the same things, right? That is, so you'll get actual value, actual zeros to be 50 and then all these zeros, and what the outcome, what are your outcome, you are getting actual ones as 1 and then the zeros as 3. That is your values. Okay, so if you find the score, this is how we predict the things. Okay, so this will come on when you practice of the things. Okay, so let's say we want to predict something. So let's say this is like we are writing the petal length and all these things. So take any random values. Let's say this is 5.6 and 8.9 or 3.4. So if we predict what species this, then what should come? Let's take up. Okay, this is a species of Virginica, right? So let's take something different. Let's say this is 12.5, 3.5, 58.5, 1.5. What is this species? Okay, still it's Virginica. Okay, so 5.0. Okay, now this is Virginica. Okay, so on basis of these things, it could manage up. Because if you see your iris data, you'll come to see the last value is 5.9, but also we are giving 12 also. but still it is predicting of the things, right? That is called as machine learning, right? That is being predicting of the things over there, right? The last value is for everything is 5, 3 and something like that, but we are giving above 5, above all these things, still we are getting the values. That is like, and if we just plot the reds plot of this data, what we have done, or the predictions you make. Simply if we run this, so plotting is not coming. So let's make separate datas. If we see the predictions of this x, so what are these and what are the values? Okay, what are these x? These are the values, right? X. Let's take some random values. Okay, as we have done here, let's take this one. That would be a logistic graph, but yes, it is. Okay, fine. So what to do? I'm gonna plot this as it's not plotting, right? So we can write it as So this is the best fit line, like you can get from there. Take a regression line plot with this, and we can get with all of them. Right, you can see the maximum, the line is taking the maximum values. See, you can find out the maximum length and all these, the sepal length versus sepal width, petal length versus petal width, sepal length versus petal width, and petal length versus sepal width. So go, or you can go with these things, right? So you get a graph, good graph over there, right? So let's give all the graphs in different colors. So all the graphs are okay. Pink is not looking good. Any different color? That is also not fine. What does the yellow will look? That is also not good. Okay, let's take any more, any different. Green, yellow, red, green, blue, violet. Violet is nice. Okay, so you are having some regression line plottings and so on. Okay, fine. So I think you might have been clear with up these things, how regression works, how this plotting seems to be. Okay, there is also a logistic regression line. Okay, so we'll now try to build up with a logistic regression model. So in logistic regression, guys, in the logistic regression, you get a graph which is always in a sigmoid graph, because there you actually get the values only in the case of 0 and 1. That's it, right? You get only the values in 0 and 1. So there you get up with those things. Okay, let's quickly plot up with things. So here we'll be going with the Titanic data. Okay, and let's load it. I think I have this data of Titanic. If I'm not wrong, I have this data, I think. Yeah, so you have passengers ID, the survival, the class, the name, their sex, the age, and all these things, right? So we'll try to make a model with this, and we'll try to actually predict the survival on the basis of this data set. Okay, that's nice, right? So quickly, let's start up finding the things. We are not going to explore the data because you know how to go with all those things. Okay, so we'll go with the data wrangling part. Any null values. Yeah, we have. So we'll see a null value. It's in processing, and let's run it again. Okay, let's wait for this process quickly. So you could see a graph actually, right? A 30 class 30 graph. These are having actually the numbers. These are having the numbers. The whole graph is having a numbers. Okay, so let's make it quite big. Only then you can see all those values. I think 100 would be fine if we run with 100. So it will give you the null values on the basis like how many null values are there in which particular cell or which particular column, like that. Okay, so we'll get an sum up of all those things there. Okay, so as we get the sum of all, we'll try to just drop on the things. Come, okay, let it be as it is. Okay, so you are getting a graph of some 100 numbers over there, and if you zoom and find, you can see some writings over here. Okay, so just remove this and out and all. That is not looking good actually. Let's also remove this line. So like you are having some cabins and some ages over here. Okay, so what our motto is to drop the things up, right? So we'll say this t dot drop the null values. So if you see, so no null values are there. That's nice now. Okay. So now we go with the feature selection process. Here we'll be seeing that which feature is important for us, which is not an important feature. So which will not be important, we'll be deleting those things. Okay. So these are the columns, right? Passenger, survive, class, and all these things. So I think this cabin is not important for me, right? This ticket number will not affect the survival of this person. The name will not affect the survival of this person. The passenger ID will also not affect the survival of this person, right? So I'll remove such things, right? And for the section, column, and all these things which are in the string value, will make it as a boolean with a discrete value, right? For that, let's say this 6 to be dummies value, and let's get the dummies of t of this 6. Okay, so if you see your dummy value, you will have this female as 1. So in the female column, if it is 1, then this is female, and if it is not 1, then this is male, right? So what we'll do, if we just delete up the first content, then also we can understand, right, that is this is a male or a female. If even if you drop the first row, sorry, the first column, So if we drop the first, and if we see the first 10 values, so you can see like that this is male, and you are getting some 1010. So if it is 0, then this is not a male. If it is 1, then this is a male. That's fine. Okay. Similarly, we'll make for every column. So let's quickly make this. For the classes too, let's make for the classes. Okay, so once these things are done, see what we'll do. So if you see your class of first 10, what you'll see, you're having second class and third class. Similarly, if you see the embark of first 10, first two, embark is not defined. So you'll get like it is having Queenstown and Southampton. So if it is 0 0, then obviously the person or the passenger would have embarked from the sea, that is Cherbourg, right? So like that. Okay. So now we'll merge this in T. So we'll say this is concat and this is T, and then the next column, then the embark, and then the class, or let's say CL, and we are just like adding up these things in the XS1, and then you see the T dot head of first value, or let's say. So you will find some discrete values over here. Now this KB in this and all these things are of no use for us. So we'll just delete those things, right? So we'll drop one by one. So we'll say they dot drop, and we want to drop these columns. Because these are not going to affect my data or affect the survival of my data. And if I give these as the input, this will make a case of overfitting, and overfitting will lead to a wrong prediction in my modelings. So if you see the head now, so you will have only these much things, right? Now you want to predict out this data. Now you want actually to predict this data. Which data? This survival. Now you want to predict the survival on the basis of all these features, right? Okay, fine. So now you split your data sets. Now say this is X and Y. Okay. Now say this is X, which is Titanic dot T dot drop, and this is survived, and give X is 1. So this is Y. So after dropping survived, everything which remains will be my training data, right? And similarly, I say Titanic, it's again T, and in the T, the survived is something which I want to predict. So this is my X and Y. Now, okay. Now if you see your X, this is your X, and what is Y? This is your Y. Okay, this is your survivals, and this is your X values, right? Now you make a logistic model there. Okay, so this linear model, you have to import the logistic regression, and take this. Now you can make your X train data, your X test data, your Y train data, and Y test data. Okay, so we'll write all these. So that is nothing but train, test, split. So it will split the training data and testing data according to you what you write. So you write test size 0.33. So 33% will be the testing data. And this will be like for once it will be taken. No module name as sk learn. Too many values to unpack. Expected 3. Okay. So X train, X test, Y train, Y test, train, test, and split. X and Y test size to 0.33 and random state to 1. So okay, this is errors. Okay, done the training and splitting part. So let's make this Titanic model, right? And pass this logistic regression here. So done, right? And then what you do is Titanic dot fit the model. What you have to fit is the training and the training data set. Okay. So could not convert to float D15. D15 is not converted. Where is the error? Shit. Why is this problem coming up? Still here, everything is fine. Head is correct. Sweep log logistic regression. You bring logistic regression. You from the model selection train split data. X test, Y train and Y test, and train split data with Y test size there. Then make it model fitting X train and Y train. Why it is not working? Could not convert this float D15. Why? Self dot X sample fit and value error. Value error it is. So this is logistic regression. Y train. X train. Okay. Oh shit. Cabin is still left here. Okay. This cabin is to be removed. Now it's okay. So now, well, okay, but again this x would be so survived. X is not having survived now, so we will have to only just delete this cabin because that is a string value and that will make some errors. And also the survived one. So survived and cabins to be removed. And that's fine now. Head is okay. Linear model done. It happened. Okay. So the train split done. Logistic regression fit. And now let's fit the data. So Titanic thought fit this X train and the Y train down. Cool. So our predictions would be Titanic dot predict the X test data. Okay, and if we see our X train, if you see the head, so you can see like the numbers has been rearranged because the data has been reshuffled actually. Okay, so similarly your test data would be also reshaped and all those. Okay, understood. Fine. So now what is your total length of X? What is the length of X? 183, right? That is 183. What is the length of X train data? So that is 122. Okay, and the length of X test data. So you are testing with 61 data. Okay, and you have fed the model with 122 data. Understood? Okay, fine. So let's go and let's take it as sklearn.metrics. Let's find the accuracy of a model. Okay, classification report, and classification report of Y test and the predictions will give all these things to you. Okay, we'll be giving all. So you want to find exactly the accurate score. You want to find the score of your model, right? So Titanic score of X and Y multiplied by 100. So we have scored some 77.59. Okay. So if we just now see that what is the predictions or the accuracy score. So sklearn and now you can find the accuracy score of Y test comma the predictions and multiply it by 100. So your model has got some 75% of accuracy. So you can predict things up to with 75% of accuracy. And get a regression plot of x and y. Must be one digit, yeah. So let's say can find the regression line. So what you get is actually the survival in the 0 axis and the first axis, right? The points will be always on the 0 and 1, and the line will not cover any of the point. Why? Because your values will be only in the 0 and in the 1. So your values are ranging on the 0 and the 1. Understood? So that is your eh, data. Okay, that is your predictions. That is your machine learning part.